Hello and welcome to this video where we're going to do an introduction to trigonometry. The learning target for this video is to understand how to apply the sine, cosine, and tangent trig functions. Now first, let's talk about some of the terminology and some of the new words here. Alright, so first of all, we have these things, sine, cosine, and tangent. Now these first two, a lot of students, they see them and they tend to mispronounce them. It's not the biggest deal in the world, but nonetheless, let's learn how we tend to refer to them. So it's not sin and cos, it's sine and cosine. So if we were actually to write out the full thing, you have sine and cosine like that. Now, what I want to do is address a core idea behind these trig functions. So now keep in mind, we're saying functions. And so what that means, if we have a function, is we're going to apply some sort of rule here. And to understand how trig really works, we have this core idea, which is we are looking at a ratio from a certain perspective. That is how trig works. It's a ratio from a certain perspective. All right. Now think about any time maybe you've been to a play, you've been to a game, some sort of sports game, like maybe like a stadium, where if you were to say left and right, it really depends on well, where are you left and right? All right. Is it especially like you're at a play? If it's the left side from the audience's perspective or from the people on the stage's perspective, because those are two different left sides, and so that kind of idea is what gets played at here with trigonometry. All right, it's a ratio from a certain perspective. And so let's kind of spell it out here, shall we? Sine, and what we're going to do is we're going to put in parentheses here, and then we put in a variable of some sort. Now, something you tend to see is this thing called theta. So let's just really quickly describe that. Theta. It's just a Greek letter, but essentially it's being used as a variable, and if we want to, we could say x, you could say y, whatever. But sine of theta is equal to the opposite over the hypotenuse. All right, and then if we have cosine of theta, that's going to be equal to the adjacent over the hypotenuse. And finally, if you have the tangent of theta, that's going to be equal to the opposite over the adjacent. Okay, now again, some of this might not be making sense yet, but just bear with me here. So the function itself of all these trig functions, sine, cosine, and tangent, is you are looking at whatever angle you're given, and you want to identify the opposite side over the hypotenuse, the adjacent side over the hypotenuse, or the opposite side over the adjacent side. Now, let me clean this up. And we have an acronym that's one of those things that, like on a quiz or a test or even your homework, is something you might just want to write down. And it's SO, CA, TOA. And this stands for sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Now, this also, one other thing we need to really express here is that these trig functions pretty much work exclusively for right triangles. Later, when you get to more complicated trig stuff, you can start dealing without right triangles, but right now, let's just say that all the trig stuff, you have to have right triangles, okay? So what I have here are two right triangles, and we're just gonna kind of go through how this trig stuff works. All right, so now what I'm gonna do is I'm gonna put a theta right here, and then we'll just kind of go about writing the different trig functions. All right, so if I want sine of theta from this triangle that's a 5, 12, 13, I want the opposite side. So we look at this. This is opposite of my angle. And then the 13 here is my hypotenuse. So sine of theta is simply just 5 over 13. And this is what I was getting at. Trig functions are just a ratio from a certain perspective. All right? And then if I go with cosine of theta, now what I want is I want the adjacent side. And so adjacent just means next to. So the side that is next to my angle is 12, and then my hypotenuse is still 13. All right. Now keep in mind, your hypotenuse, that's the one that's the biggest side, so the biggest number, the one that's opposite of your 90-degree angle, that's the one that's going to be your hypotenuse. So that one's always going to be the same. And then if I do tangent of theta, that's going to be the opposite over the adjacent. And so that's just 5 over 12. And that's it. All right. Like I said, trig functions are just a ratio from a certain perspective. Now, let's continue to explore that idea. Ratio from a certain perspective when we start to label these angles slightly differently. So now, I'm going to go X, I'm going to go Y. All right? And like I said, we can put what we want in there. The theta, it's just kind of a stand-in saying, so we're talking about an angle. And we tend to use theta to say that we're not really talking about a side length because for the longest time, X usually corresponded to like a length of like a line or something. But really, it's just a stand-in. So it's all good if we want to use X and Y, theta, alpha, beta, whatever you want. Okay, now anyways, let's do this twice. And actually, wait, I need to undo something really quickly. I want Y to be in red. All right? So what we're going to do is we're going to find the sine of x, we're going to find the cosine of x, and we're going to find the tangent of x. Then we're going to find the sine of y, cosine of y, and the tangent of y. All right? And this really hopefully hammers home that point that we're looking at a ratio from a perspective. And depending on where we're at, that perspective changes. That ratio could change. All right? So if I'm looking at sine over x, here's my x. And so I want the opposite over the hypotenuse. Now, 25 will always be our hypotenuse. All right? So opposite is going to be 7 over 25. If I look at cosine, now I want the adjacent side, which is that one. So that's 24 over 25. And then tangent, again, looking at the x, I want my opposite and my adjacent. So that's going to be 7 over 24. All right, now let's switch gears and let's take a look at y. You have to see, I have to clean this up just a teeny tiny bit. Oops, let's undo that. We'll let that just stay there. Okay, so like I said, 25 is still my hypotenuse. But now I'm at a new perspective, all right? And so what is opposite of my y is now 24. So that's the opposite. And what's adjacent is now 7. So what that's going to do is it's going to flip, or it's going to not really flip my ratios, but it's going to rotate them a little bit, if you will. So sine is now going to be 24 over 25, whereas it was 7 over 25. And now cosine is 7 over 25. And then what we're going to see here is that the tangent of y is 24 over 7. And so if you take a look here, notice how those guys switched places, all right, because we switched our perspective. Like it was like the analogy I was using. If you're at a play, if you're in the audience, what is to the left for you is not what's to the left for the people on the stage, right? And so you have to kind of, it's the opposite. And that's exactly what happens here. What becomes sine is cosine when you look at a different angle. And then for tangent, the thing that happens is they just flip around. So we get the reciprocal. And again, that has to do with the perspective. So the main takeaway we have from all of this is that trig is a ratio from a perspective. It really matters where it is. And so the first thing you should do is once you get that triangle, identify what is your opposite, what is your adjacent, and what is your hypotenuse. After that, the function is just writing fractions. Pretty doable. Anyways, good luck with your homework or practice, and let me know if you have any questions.